The next most complicated motion that a charged particle can have in the presence of a uniform magnetic field is if the velocity of the particle is not entirely perpendicular to the magnetic field line. What's going to result is the charged particle is just going to oscillate around the magnetic field line due to the part of its velocity perpendicular, but the part of its velocity that's parallel to the field line doesn't change. There's no acceleration of that. So the trajectory of the particle is going to trace out a helix. One of the things we're asked is, at this trajectory for this particular particle, can we determine if it is a positively charged particle or a negatively charged particle? So for its trajectory, I'll pick that to be its point we're going to analyze. So there is the velocity. Magnetic field is straight up, and the magnetic force, since it's going around on the helix, is going to be in towards the center of the path, so in towards that magnetic field line. Now, that should be enough for us to figure out if this is a charged particle that is positive or negative. And just to highlight that, if Q is positive, then we'll know the magnetic force is parallel to V cross B. And if Q is less than 0, so it's negatively charged, then the magnetic force will be parallel to minus V cross B. All right? So let's see what direction V cross B points. V cross B going up the page is going to be directed out, away from the helical path, so it actually would bend in the opposite sense if it were a positive charge. Since V cross B is pointing out, away from the magnetic field line, then this must be a negative charge. The magnetic force is directed in towards the magnetic field line. Now, if the magnetic field is uniform, then this is all that can happen, is that the charged particle will just keep gyrating around a magnetic field line, and the component of its velocity that's parallel to the magnetic field line can't change. So we just take this velocity and think about that vector for a little bit to see how to break it down. So there's our whole velocity, and we have a magnetic field line, like so. That velocity is going to have a portion of it that is perpendicular to the magnetic field line, and that can be accelerated by the magnetic force to go around and round in a circle. And then there is a parallel component to the velocity that can't change. Now, if the magnetic field is not uniform, then you can get what is called a magnetic bottle. This is basically what populates charged particles in the magnetic field for the Earth. All those magnetic field lines are converging at the poles, the magnetic poles of the Earth. So the magnetic field is getting stronger there, and instead of just gyrating around a magnetic field line, given particle will get to the point where the motion actually reverses. hence the name of the magnetic bottle. So the increasing magnetic field will reflect the particles, and they'll then gyrate and follow the magnetic field line in the opposite direction. So the radiation belts for the Earth are charged particles that are trapped on our magnetic field lines, and they just bounce back and forth from pole to pole to pole.